Following on from the previous video, we were trying to work out this volume here, and we got to this stage here where to describe this sphere in 3D space, all that's required is this. So in spherical coordinates, to describe this sphere, all that you need is this. So now to work out the volume V. So to work out the volume V, we need to set up our triple integral. So looking at this inner integral here, you need to think in terms of the radius now. In your mind, think in terms of the radius. So the radius is moving like this. So let's say you're currently pointing here. Well, you're actually integrating from here to here. So looking at this radius here, you're moving along in terms of the radius, and then you start to integrate when you get to here, and then you stop when you get to here. So you're interested in this region here. So hang on, let's increase the angle. So you're moving along the radius because we are talking about this integral, and you have to think in terms of the radius. So you're moving along this radius. You start integrating when you get to here, and then you stop integrating when you get to here. So you start here, and then you stop here because we're interested in this region here. Okay, so remember, hang on, let me just go over it one more time. You got to think in terms of the radius. So let's look at this radius here. So thinking in terms of the radius, you're moving along like this, you're moving along, and then you start to integrate when you get to the small sphere. This is when you begin. So this is when you begin, and then you stop when you get to a radius of 2. Stop when you get to a radius of 2. So really, you're integrating from the small, you start at the small sphere, which is this thing here. So this will be 2 cos phi, and then you stop when you get to the outside, when you get to the big sphere. Well, this big sphere has a radius of 2, so it has a radius of 2. So that will set up our first part. Now look at the next integral. So the next integral would be, hang on. The next integral, hang on. The next integral would be thinking in terms of the angle phi. So remember, phi is moving along like this. So phi is scanning along like this. Up, well, from an angle of 0 to an angle of 90 degrees, which is pi over 2. Pi from 0 to an angle of pi over 2. So yes, so it's actually doing this. It's actually doing this. It's actually doing this. It's actually doing this, and so on. And then now for the last one, you've got to now think in terms of the angle theta. So theta, you've got to, in your mind, picture the xy plane. So picture the xy plane in your mind, and theta is this angle here. This is theta. This here is theta. So thinking in terms of theta, you're actually scanning from an angle of 0, and then you're scanning all the way around like this. You're scanning. So in your mind, think of the xy plane. So you're actually scanning from an angle of 0 to an angle of 2 pi. So this whole thing here boils down to us evaluating this. So remember, you're in terms of the radius, you're doing it from here to a radius of 2, and in terms of phi, you're doing it from 0 to 90 degrees, and in terms of the angle theta, you're doing it from 0 to 2 pi. So the volume's given by this whole thing here. So now it's just a matter of integrating it. So looking at the inner integral, we've got to integrate this with respect to the rate, with respect to rho. So this thing here would be a constant. So we're integrating it. So when you integrate this rho squared, it will be rho to the power 3, and then you've got to stick this a third in there, a third. And then remember, this is a constant, so this will be a constant from here to 2, from here to 2. So that will then take us to here. So now put this 2 into the row. So this thing here will become 8. Hang on. This thing here will become 8. And then put this whole thing here, hang on, put this whole thing here into the row here. So when you cube it, it will become 8. And when you cube this, it will become cos cubed. And then you've got your constants here. You've got your constants here. So that will then take us to here. Okay, so now integrate it again with respect to phi. So when you integrate this, it will then give you negative cos, and then you've got your constant. It will give you this thing here. And when you integrate this, you could use substitution, but notice that sine is a derivative, near enough the derivative of cos. So rather than using substitution, just make this to be your initial guess. So when you differentiate this, it will be 4 cos to the power of 3 phi times the derivative of well, it would be this. You should know this by now. And then you don't want this 4, so you go back to here and then negate the 4. Oh, sorry, you got to have a minus in here when you differentiate it. And then you want this 8 over 3, so you stick 8 over 3 in there. So when you differentiate this now, it will become negative 8 over 3 cos to the power of 3 phi sine. Well, I'm expecting you to be able to integrate this. So when you integrate this, it will give you this thing here. Okay, I'm expecting you to be able to integrate it. So integrate this, it will then give you this thing here, from 0 to pi over 2, from 0 to pi over 2. So now stick this into here. So so cos of pi over 2 is 0 here. So this thing here will be 0. Stick this into here. Cos of pi over 2 will be 0. So that would be 0. And then you take away and then put 0 into here. Cos of 0 is 1. So you take away minus. Well, this thing here will become this thing. And then put 0 into here. This whole thing here will then become this. And then simplify it. It will then give you the number 2. And then integrate this with respect to theta. That will be 2 theta from 0 to 2 pi. From 0 to 2 pi. Put the 2 pi into there. Take away blah blah blah. It will give you 4 pi. So our volume is 4 pi. So now let's use high school maths to double check our answer. Remember, the answer is 4 pi. Now let's use high school maths. From high school, the sphere is given by this. So we want half of the big sphere. Half of the big sphere. Take away the small sphere of radius 1. So when you put 1 into here, this is just 1. So 4 pi over 3. And then tidy this up. Blah, 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 blah. And it will be 4 pi. So it's correct. So our answer is correct. The volume is 4 pi. Okay.